Good evening, Rancho Verde High School pre-calculus students. This is Mr. Langston coming at you. Today is September the 12th, and we are going to go over section 2.4 of the textbook, which is complex numbers. So, we got to warm up first because we did synthetic division yesterday, so let's give it a shot. First thing you do, you notice it's divided by x plus 5. So, we are going to take the opposite of adding 5 or plus 5, which is negative 5. So we got negative 5 right there. Going to give us some room. Now, I already have this in descending order. So this is 1x cubed minus 5x squared minus 7x plus 4. So what I'm going to do is put a 1 there, put a 5, put a negative 7, and then put a 4. And first part of long division, you bring down that 1. Negative 5 times 1, well, that's going to be negative 5. And now combine them. So that's negative 10. Negative 5 plus negative 5 is negative 10. Negative 5 times 10. Positive 50. Sorry, I had that negative there. So positive 50 minus 7, which is 43. And lastly, negative 5 times 43, so that's going to be negative 215. When I combine it right there, you're going to get negative 211. This is my remainder. So what I have is 1x squared minus 10x plus 43 minus 211 all over x plus 5. So again, let me just rewrite it here. X squared, because I don't need this one. It's just x squared minus 10x plus 43 minus 211 all over x plus 5. And there you are. That's our warm-up. I've cleansed the daemon. So we're doing complex numbers, which our focus standard, of course, is complex numbers. We're still in Chapter 2, polynomial and rational functions. And if you did not grow up in the 80s or live in the 80s, you actually have no idea what that just meant. So our power standard is a 10 to precision. Our language objective is that students will be able to communicate with each other regarding how to solve arithmetic operations involving complex numbers. So without much further ado, we are going to jump directly to concept numbers. Now, two things you need to know. First, you have I, and I'm just going to rewrite it here. I is equal to square root of negative 1. Kind of a little weird thing there. So I is equal to square root of negative 1. You need to memorize that. You need to know it, live it, love it, everything like that. I is square root of negative 1. Now, another thing you need to know is if I square both sides, I'm going to get I squared equals negative 1. You need to know that too. Okay? If you memorize anything, this needs to be memorized. In fact, just know it. So, complex numbers are composed of real numbers and imaginary numbers. So this right here is the real component, this A. The plus BI is imaginary. Imagination. And if you don't watch South Park, you wouldn't even know that. So, operations with complex numbers. Okay, blah, 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 blah. What you really need to know is that when you are adding or subtracting complex numbers, you add the real or subtract the real parts with the real and the imaginary parts with the imaginary. So I'm going to totally skip this little description and let's just jump to an example because you're going to get it once we see an example. So you have 4 plus 7i plus 1 minus 6i. What you need to do is, it's basically like combining like terms. So you have the real components of the number. You got 4 plus 1. All right. 4 plus 1, 5. And now you have the imagination, the imaginary parts. So you have 7i plus a negative 6i. 7i plus a negative 6i, that's going to be plus 1i. Right there. So that's kind of silly saying 1i. It's just like me saying, 1x. No, you don't even say that. You just say x, okay? So I'm going to get rid of this plus 1i, and I'm just going to write it as 5 plus I. There you go. That's your new imaginary number. Moving right along, right along, right along. You have 3i minus a negative 2 plus 3i. You know what? I need to make this larger, don't I? I think I do. Okay. So there you go. Got it a bit larger. 3i minus a negative 2 plus 3i minus quantity 2 plus 5i. All right, so what do? Well, it's just like any other type of number, or shall I say any other type of concept. Don't know why I did that. That's weird and freaky. Not right. Let's go back. Put a little arrowhead. There you go. You're going to distribute the negative. Really, you're distributing a negative 1, but I just say distribute the negative. It still works, okay? So 3i minus a minus plus 2 minus a plus minus 3i minus a positive minus 2, and then minus a positive here minus 5i. Right there. So next thing you're going to do, it's basically combining like terms. Combine the reals with the reals and the imaginaries with the imaginaries. But before I do that, I can realize that, hey, I got 3i minus 3i. What do you know? Cancels right out. I got a positive 2 and a negative 2. What do you know? Cancels right out. I'm left with negative 5i. Now, you don't need to put down your real component. You can just leave it like that. That's perfectly fine. So there you go. And next, we need to multiply complex numbers. Well, first off, you need to understand is you can treat the i's just like variables. Okay? They have the same, shall I say, je ne sais quoi, same characteristics. So I have 4 times the quantity of negative 2 plus 3i. I can take and distribute the 4 right there. Distribute. So I end up with 4 times a negative 2, negative 8. 4 times a positive 3i. All right. Positive. My inner pad's acting a little wonky right now. Positive 12i. And there you go. You distributed it. Yes, it's that simple. Oh my God. So next, you have 3 plus 2i times the quantity of 3 minus 5i. Okay. For this, like I said, you can treat it like you do your variables. So I'm going to use the stacking method for multiplication that I showed you guys. And please, by the way, use it. So I have 3 plus 2i times 3 minus 5i. So I have negative 5i times 2i. Negative 10i squared. And that's really an ugly negative. I don't know why it's doing that. Negative 5i times 3. Negative 15i. Placeholder, because I'm done with the negative 5i. Now I've got 3 plus 2i. 6i. And then lastly, I've got 3 times 3, 9. So negative 10i squared plus 0, well, it's just negative 10i squared. And we got over here minus 9i, and I got a positive 9. So here's the thing where I told you, if you're going to remember anything, remember these two, because this is important. I squared is equal to negative 1. So when I go back, when I go back, I squared I have over here, I'm going to put in its place negative 1. So I got minus 10 times negative 1 minus 9i. 10 times negative 1, well, that's negative 10, but don't forget about this negative. So negative is a positive. So it's positive 10. 9 minus 9i plus 10. Now you're going to combine the 9 and 10. Combine your real parts. Combine like terms. So I have 19 minus 9, and then I'm done. So next thing we have, you need to find the quotient of complex numbers. This is where something called a complex conjugate comes into play. Complex conjugate. Now, remember I taught you some rules that we can't have. We can't divide by 0. We can't have a negative in a square root. Well, we're learning we can. Another thing that we don't like is having an improper fraction. So, and that's where the numerator or the top number is larger than the denominator or the bottom number. Okay? Another thing we don't like is when we have an imaginary number in the bottom of a fraction. Ask me why, I don't know. We just don't like it. It's something that's just, you don't do. Okay? So, what are we going to do about this? That's where a complex conjugate comes into play, because a complex conjugate, when you multiply complex conjugates with each other, the i's disappear. So a complex conjugate is exactly the same as the binomial, except it's a different sign. So in this case, positive sign, exactly the same, but a negative between them. So I have 2 plus 3i, 4 minus 2i. I need to get rid of the imaginary number in the bottom. So I'm going to multiply the top and the bottom by the complex conjugate of the bottom, which is 4 plus 2i. Now I'm multiplying both the top and the bottom, 4 plus 2i, because 4 plus 2i over 4 plus 2i, well, that just simplifies into 1. So I really didn't, quote, change the fraction, or I didn't change the value of the fraction. I just displayed, or changed how it's displayed. It's like me saying this. I have 1/2, and I'm going to turn it into 4/8. Well, 4/8 is still 1/2. I didn't change its value, but I changed how it's shown to you. So when I multiply this out, I'm just going to do the stacking method twice. So let's just do the top right now. I have 2 plus 3i times it by 4 plus 2i. When I multiply it out, 3 times 2, 6, I times I squared. 2i times 2, 4i. Placeholder. 4 times 3i, 12i. 2 times 4, ocho. So I add them up. 8 plus 16i plus 6i squared. Well, I know that I squared is -1. So I have 8 plus 16i plus 6 times -1. That ends up being -6. And when I combine it with 8, I'm going to get 2 plus 16i. That is my top. 2 plus 16i. That's my numerator. So let's find the denominator. I'm going to do that over here. I have 4 minus 2i multiplied by 4 plus 2i. That's a plus. That's an ugly plus. I got to fix that. And plus. Okay, so I have positive 2i times -2i, -4i squared. 2i times 4, 8i. Placeholder. 4 times 2i, -8i. 4 times 4, 16. These two cancel out. So I have 16 minus 4i squared. Well, we know what 4i squared is. Remember, I squared is -1. So 16 minus 4 times -1. Well, that becomes a positive 4. 16 plus 4, 20. So what I have is all of this is over 20. Now, I can break up the top of this fraction. I can put everything over 20. So I have 2 over 20 plus 16i over 20. And now I can simplify. 2 over 20 becomes 1/10. And 16i over 20 becomes 4/5 I. That, my friends, is my answer. So, next thing I have right here is I can deal with square roots. So I know that square root of negative a is the square root of a times I, because negative a is -1 times a. And I can break that up into square root of -1 times square root of a. And that just ends up being, this ends up being I times a, or sorry, times square root of a, which is square root of a times I. Now, I don't know, this book kind of likes it writing like square root of a times I. I have also seen it written as I root a. Whatever. I don't care. However you like to have it. So I have square root of -3 times square root of -12. Okay? I can take square root of -3 and I can break that up into square root of 3 times I. And square root of -12, I can also break that up into square root of 12 times I. So when I do that, I can multiply these out. So what I have is square root of 3 times 12, 36, and I times I squared. Square root of 36, you should already know that's 6. And I squared, well, that's -1. So my answer is -6. And there you go. So I got 2 problems from your homework that I'm going to do to help you out. First off is I have this one where I have 15 plus square root of 15 plus square root of 12i times square root of 15 minus square root of 12i. First off, you should be able to look at it and say, like, wait a second, they're complex conjugates. Yeah, they are complex conjugates. You're right. So I know my i's are going to end up disappearing. So what I'm going to do, stack them, because I like the stacking method of multiplication better. It's just me. Square root of 15 plus square root of 12 I times square root of 15 minus square root of 12 I. So I have square root of 12i, negative square root of 12i times positive square root of 12i, which is negative square root 144i squared. And I don't care what this is because I know the middle is going to cancel out. So I'm just going to say square root of 15 times 12i, and that's i's on the outside. And that's negative, by the way. And I have, now I'm done with multiplying this times this times this. So I'm going to put my placeholder, boom. And I'm going to do 15 times square root of 12i. Well, that's square root of 15. Wow. See that? I saw it. Square root of 15 times 12i. And that's positive, by the way, so I just put a plus sign there. And I have square root of 15 times square root of 15. Square root of 2, I think it's 225. I don't remember this off the top of my head, and I don't know why, but whatever. We'll just roll 225. So, when I combine like terms in this one, these cancel. Stacking method. Remember, stacking method rocks. So, negative square root 144 I squared. And I have over here square root of 225. I'm going to take this and I'm just going to kind of bring it together. So square root 225. There we are. So we got rid of that. Now, we already know square root of 225. We got that. That's 15. Square root of 144. Oh, that's 12. I squared times negative 1. So I've got 15 plus 12. All right. 27. And there you are. It's cool. It's cool. Now, next type of problem. You need to find the roots for x squared plus 6x plus 16, and I forgot to say equals f of x, or usually we say f of x equals x squared plus 6x plus 16. Whatever. So, to find the roots of this, first off, you should realize that it's not factorable. So what we're going to have to use is the quadratic formula. Everybody's favorite formula. Yes, it is. No, it isn't. I understand. So you have x equals negative b plus or minus square root of b squared minus 4ac all over 2a. And a is 1. B is 6, C is 16. So I got negative 6 plus or minus square root of 6 squared minus 4 times 1 times 16. And that's all over 2 times 1. Now you're asking yourself, dude, why do I care? How does this have anything to do with complex numbers? Well, it's because this polynomial function has no real roots, which you're going to see. So I'm going to rewrite it here. Negative 6 plus or minus square root of 6 squared, which is 36 minus 64. And that's all over 2. Okay, well, 36 minus 64. What could that be? 28. Negative 28. So I have negative 6 plus or minus square root of negative 28 over 2. Now, this is why it's imaginary, because under the square root, I get a negative. So 28 is 4 times 7. I can factor out the 4. That's a perfect square. So I have, and I'll rewrite that here, negative 6 plus or minus square root of negative 1 times 4 times 7. Well, I can take a square root of negative 1. That's I. So I have, I'm going to put it right up there. Negative 6 plus or minus, I have I, because square root of negative 1 is I. Square root of 4, 2. So it's 2i. And then I have square root of 7 still inside the square root. And that's all over 2. I can split this numerator up. So I have negative 6 over 2 plus or minus 2i root 7 over 2. Well, 6 over 2, negative 6 over 2, becomes negative 3. And that's plus or minus 2i root 7 over 2. Well, the 2's cancel out. Boom, boom. So it's plus or minus I root 7. So I have one root of negative 3. Oh, why did I put the comma? Negative 3 plus I root 7. And when I say one root, I mean x can be negative 3 plus I root 7. And the other x, so x1, and I have x2, which is negative 3 minus I square root 7. Yay! Well, that's really it. That's all I have for you. You have 20, maybe 22. I'm not quite sure. We'll split the difference, say 21. Homework assignment questions, it's already on the webpage. So if you have any questions, you can always email me, text me, go through my remind, anything like that, or you can wait until tomorrow to ask me because, well, that's what some people do. I'd be more than willing to help out. That's about it, you guys. I hope you have a good evening. You take care and drive safe, or if you're not driving, just be safe. So, peace. Bye.